So our next topic is going to be vertex form of parabolas. Now, when we take an equation for a parabola, there's actually a few different kinds of equations that you can do. The three most common ones are vertex form, intercept form, and standard form. We're going to focus on vertex form and intercept form in this particular class. So today we're looking at vertex form. All right, so vertex form looks like this. Now, this one has a whole bunch of letters in it. In an actual equation, like this A and that H and that K, those would all be numbers. Okay, so you can kind of see as you look down the page, this is what they're going to look like. Okay, so you're going to have numbers most places with just the X and the Y as your variables. Right, and the cool thing about vertex form is that each of those numbers tells you something about the parabola. Okay, so first of all, the H and the K, that tells you what your vertex is. Okay, so it's H and then K tells you what your vertex is. Now, there's only one little tricky thing about that, and it's the fact that there's a minus sign right here. Okay, so there's a minus sign built into the equation and then the H. We just want the H, not the minus sign. So when you look at an example like this one, there's the minus sign, H would just be 1. But on this one where it's a plus sign, that's like a minus -3. So H is actually -3, okay, which seems a little bit weird. So how I kind of think about it is I just think about this one as it's backwards, right? It's not really backwards, but I think that's the easiest way to think about it. If this one says +3, then H is going to be -3. If this one says -3, then H is going to be +3. I'm sorry, -1, it'll be +1. Okay, the K is just exactly what it looks like. K is -4 on this one, and it's -5 on this one. Okay, now the other thing that you can tell is whether your graph is going to have a minimum or a maximum. Okay, so your graph has a minimum point, meaning it's going to open. So minimum point, meaning your graph will open like this, right? And that happens whenever your A number, this guy right here, is positive. That's when you're going to have a minimum. All right, and you're going to have a maximum when your graph looks like this, anytime A is negative. Now, how big of a number A is also has a difference. It makes a difference on how your parabola looks. But for right now, we don't really care about that part. This is all that I want you to be able to tell, is if it's going to open this way or if it's going to open this way. Okay, so what can we do with that? So here's some examples, and let's take a look at those two features. So the first thing that we want to be able to do is say, what's the vertex on this particular graph? So with this guy right here, my vertex is going to be the point H comes from here, so that's backwards of what it looks like. So it's going to be -3, and then it's just whatever this number is. So -3, -4 is my vertex. All right, and since this number right here is a negative number, that tells me my graph's going to open this way, and it has a maximum. So this one is going to have a maximum point. Okay, the vertex will be the maximum point. Okay, this guy over here, my vertex. So again, this one backwards of what it looks like. So that's going to be +1. And then this guy just exactly the way it looks, -5. All right, and A in the front is positive. So my graph's going to open this way, and it's going to have a minimum. So my vertex is a minimum point on that graph. Okay, great. Well, you might be thinking to yourself, why on earth do I care? Why do I care what the vertex is? Why do I care if it has a minimum or a maximum? So let's look at an example. So we talked about before about how the parabolas model a whole bunch of things. So this is a ball. So the ball goes up and then comes back down. So when we draw a diagram of the ball's path, not really looking for too much here. So here's going to be my little coordinate plane. And basically what this tells me is that the ball is going to go up and then it's going to come back down somewhere. Okay, and I know that it's going to look this way, right? It's got a maximum because my A value is negative, right? So if A is negative, that's how I know it's going to look like this. And also, you just probably know how a ball works, right? And the only other thing that I can really add to this guy is I can add the coordinates of this point up here because that's my vertex, right? So the coordinates that point, it's going to be +8 and then +15. Okay, so what questions can we answer about this? We want to know about the path that this ball takes. So the first question, how high does the ball go? right? Well, the maximum height of the ball is at the vertex, right? That's the highest point it gets to. So to answer this question, I just need to know which one of these two numbers tells me the up and down part of this point, right? So remember how points work. You run and then jump. And we want to know the height. We want to know the jump part, right? So that would be the 15. Okay, so the ball is going to go 15. It doesn't actually say if it's feet or not, so I'm going to go ahead and write feet. Okay, and then question 2 is how far sideways does the ball go before it hits the ground? So I want to know how far is it from here to here? Okay, well, we don't have numbers for either of those points, but here's what we can figure out. We've talked before about how parabolas are symmetrical, right? So what that means is there's something called an axis of symmetry. It's like a fold line that goes right down the middle, right? And in this particular guy, it's the same on either side. It doesn't quite look it because my sketch isn't perfect, right? But it should be the same on either side. So what does that tell me? Well, this up and down line that goes through the middle, that goes through your vertex. So if I run 8 to get to the vertex, that means that this part right here must be at 8. So from here to here, you go 8 units. And since it's symmetrical, from here to here has to be the same 8 units. So how far is that going to be altogether? Well, 16 feet or whatever the units are, yards, miles, inches, I don't know, right? But it went 8 and then it went another 8. So 16 altogether. Okay, and those are the key features of vertex form. Vertex form is really easy to work with because you can basically just pull the numbers right out of the equation and then be able to figure out some easy stuff about it. So from an equation in vertex form, you should be able to find the vertex, and you should be able to find the distance between your two x-intercepts. So that distance right there.